A stadium has a seating capacity of 15,400. Calculate the number of people in the stadium when 75% of the seats are occupied. Candidates see this as very simple and just multiply 15,400 by 75%. 75% is 75 over 100. That is correct. They don't even bother to simplify the fraction by a common factor, like striking of two trailing zeros in each case. They do not bother to do that. They just use their calculator and presto. So we have, that is, if we simplify by a common factor of 100 in the good old-fashioned way of striking off two zeros in the denominator and two zeros in the numerator, then we just have 154 multiplied by 75, which they just use their calculator and presto, the answer is given. The problem values 1 mark. It should therefore be as easy as that. However, in order to be true to principle, pay special attention to the following explanation. We are going to be true to principle. Pay attention to the following explanation, because we do things all the time in mathematics and don't know why. I am attempting to show you why we do things like these, things that we take for granted, that are heavily based in principle, and we just do them, we take them for granted. There's your answer. 11,550. The same problem. A percentage is a reference number. It compares every whole to another whole that is divided into 100 equal parts. That is what a percentage is. It is a reference number that compares whatever whole you have to a whole that contains 100 equal parts. 75% of the seats are occupied. What does that mean? 75 out of 100. And if we compare 15,400 to a whole divided into 100 parts, if we take 75 of those 100 parts, how many parts would we be taking of the 15,400? That is what we are saying. The full stadium is compared to the 100 parts in the whole that we have right here. So the 15,400 matches with the 100 parts of a whole. But of that whole that contains 100 parts, we are taking 75. Therefore, what number do we place in the numerator that is equivalent to 75? The 15,400 is equivalent to the 100. Then what number will be equivalent to the 75? The number of seats that represents is compared to 75 of those 100 equal parts. But we do not know what that number is. This is a number that we do not know. The entire capacity of the stadium is considered to be a whole that is divided into 100 equal parts. If that whole is divided into 100 equal parts, then we are taking 75 of those 100 equal parts. Then how many parts will be taken of the 15,400? That is the number that we need to find, which is presently unknown. we have an equation with unknown x being divided by 15,400. X is divided by 15,400. We therefore need to find x, and we will do that if we eliminate this 15,400 that we are dividing by. Since we are dividing, we will do the opposite of division, which is multiplication, and we will multiply that left-hand side, which contains this fraction. We will multiply that by 15,400. But we know that we cannot do that to one side of an equation and be correct. We have to balance the equation by multiplying the right-hand side by 15,400 also. What happens here is that the 15,400 that we are dividing by on the left-hand side is entirely eliminated, and on the right-hand side we have 15,400 multiplying 75. And of course, that is all over 100, which is the same expression that we had on the previous slide, to which we already know the answer. And we are no doubt just being formal, carrying it out right here. Also, simplifying by a common factor of 100 in the good old-fashioned way, then we just say 75 multiplied by 154, and that gives us 11,550. There is really no need to go through that length in order to solve the problem, just for 1 mark. However, we do this all the time without being able to explain why. So it is that we do it all the time without being able to explain why. And we are going through this length only to explain why, because we show that we could have finished the problem in a matter of seconds on the previous slide. For access to hundreds of free videos, please subscribe to our YouTube channel, Richard James Mathematics Resources. For unlimited access to thousands of exclusive full-length videos, please subscribe to our Vimeo channel, Richard James Mathematics Resources.